Mr. Elegante here from A Plus College Ready, here to tell you, what can light tell us about an atom? First, you need to understand something a little bit about light. Light is caused by electrons jumping from a lower energy level to a higher energy level. Why would they do that? They've absorbed energy. Could be electricity, could be fire, could even be friction. Whatever causes the electron to absorb energy, the electron jumps up from a lower energy level to an excited state, a higher energy level, and then it jumps back down. And when it jumps back down to that ground state or that lower energy level, it gives off a single photon of light. That single photon of light has an energy associated with it that matches the difference in the two energy levels. The electron can make all kinds of jumps, 1 to 2, 1 to 3, 1 all the way to the fourth energy level, and then fall back down from the fourth to the first, or from the fourth to the third. Being able to make all those different jumps, it'll create different bands of light. Each band of light has a certain energy associated with it. We call all of those lights given off the emission spectrum. Light can act as both a particle and a wave. As a wave, it has a wavelength, the distance between the top of one wave and another, and a frequency, how frequently a wave passes a certain mark. Like standing in the ocean and saying, how many waves per minute hit me? We know that light of different energies, red has low amounts of energies, violet has more energy, can actually knock loose electrons. When it knocks loose electrons, we call that the photoelectric effect. And you may have a solar calculator that uses this to generate electricity. You may have seen solar panels that are used to create electricity by knocking loose electrons using light. In the picture down here, you'll notice the red light does not have enough energy to knock loose those electrons, while the green and the blue light do. Because different kinds of light have different energies, we can therefore draw conclusions about the amount of energy that each electron has. Not only is light given off in the visible spectrum that we can see, light is also given off in parts of the spectrum we can't see. So over here on the Lyman series, this is ultraviolet light. This has far more energy, and you can tell because it's making a much greater drop than the infrared energy over here. Infrared light is associated with lower energy, and most television remotes work on an infrared transmitter. It's actually shooting infrared beams of light at the TV. The visible emission spectrum of hydrogen is given here, but you can tell in this picture there's a lot more to it. There's light both in the UV and in the infrared. Every element has its own emission spectrum. Hydrogen, mercury, and neon all give off different bandings of light, and we can use this to identify what things are made of. This is the reason why Robert Bunsen discovered so much about elements using his Bunsen burner. He stuck them in the flame and noticed they gave off light, and by breaking that light into all its constituent colors, he was able to learn a great deal about the different elements that surround us. We know that the speed of light is constant in the universe, and that the wavelength of light, measured in meters, multiplied by the frequency of light, measured in hertz or inverse seconds, 30 waves per second, is equal to the speed of light. Therefore, if we know the wavelength, we can find the frequency. We can also look at a certain wavelength or frequency of light and calculate the energy associated with that light.